You're going to be so happy to know that there are only 6 slides to this video. Tonight we're going to talk about sigma notation. Alright, so what is sigma notation? Well, if I have a sequence, or a series, U1 plus U2 plus U3 plus U4 plus however many terms you have until you get to UN, I can write this. I told you, mathematicians are really lazy. They don't really like to write. So they use symbols or another language for shorthand. Well, they use this symbol here. That's called sigma. It's a capital S if we were writing in Greek. Actually, we are writing in Greek. And we can write this sequence here, or this series here, U1 all the way to UN, as this little tiny block of strange letters here. So how this reads is the sum of all the numbers of the sequence or the series U sub R, where R equals 1, 2, 3, all the way up to N. So this part right here means take the sum of. In English. So take the sum of. This part right here, that's a series. Usually it's a formula for a series. R equals 1. This is called your index. And it means start with your first term. Right there. That 1 means start with your first term. I like A sub 1, but this here uses U, so we'll stick with that just to be consistent. And then this means end with the nth term. Okay, so we're writing a bigger sequence like this in shorthand. All right, I'm going to show you an example. So I'm going to do 2 things here. I have this series right here, and I'm going to expand it, and then I'm going to find the sum. That's 2 different things. Expanding it just means that you're writing it out. You're expanding this out into its series in the way that you're used to seeing a series, and then finding the sum of it means that we're going to actually add it together, because this is a finite series. This has terms 1 through terms 7. So I'm going to go ahead and expand that. So in order to expand it, I want to find, I'm going to call this A1. And once I expand it, it's going to be in this form. You don't have to go through all these, oops, that's a 7. You don't have to go through all these steps every time. I'm just showing you exactly what you're doing. You're taking this series and you're going to expand it to include terms 1 through 7. All right, so to get the first term, I need to plug in I need to take my 1 here and plug it into R. All right, so that's A1. A2 is going to be, I need to plug in a 2 to get my second term. To get my third term, I plug in a 3. And to get my fourth term, I plug in a 4. Fifth term, plug in a 5 into my series formula there, and a 6. And finally, I end with 7 because that's the last term. Okay, so that's what this looks like when I expand it. to go ahead and do a little bit of work with this. And now I'm going to take the sum. The sum is 35. Sue me if I'm wrong. Okay, now I have one for you to try. Go ahead. I want you to expand this and then find the sum. Restart this when you're ready to check. Okay, so the problem needed a little work. Your example was a little different than the one I have here. The one you have is better. Okay, so first thing we're going to do is expand it. And this means that I want to start with the third term. So I want A3, A sub 4. I want the fifth term, and I'm going to stop with the sixth term. Start with 3, end with 6. The third term. In order to get the third term, I need to plug a 3 in everywhere there's an n. So you'll notice this isn't an arithmetic or geometric term. That's okay, you can have all kinds of sequences or series. We mainly focus on arithmetic and geometric, but it doesn't have to be that. So the third term of this sequence is 1 over 2 to the third plus 3. The fourth term is 1 over 2 to the fourth plus 4. The fifth term is 1 over 2 to the fifth plus 5. And finally, the sixth term is 1 over 2 to the sixth plus 6. I'm going to test our fraction knowledge here. 2 to the third is 27. Ugh, that's going to be tough. No, 2 to the third is 8. That's a lie. That's 3 to the third. 2 to the third is 8. And then 1 over 8 plus 3 is going to be 25 over 8. All right, 1 over 2 to the fourth is 1 over 16. Plus 4 is going to be 65 over 16. 2 to the fifth is 32, so 1 over 32 plus 5 is going to be 161 over 32. And 2 to the sixth is 64. 1 over 64 plus 6, I believe, is 385 over 64. All right, so this is expanded. I'm going to go ahead and combine all these terms. 8 times 8 is 64, so that'll be 200 over 64. 65 times 4 is 260 over 64. I'm just changing these so they all have one denominator so that I can go ahead and add them. 161 times 2 is 322. Dear God, don't get hung up on the fractions, please. When I end, I should have 783 over 64. If you're allowed a calculator on a test, and I probably would give you one for this problem, you can go ahead and add these in a calculator. Just put I just don't happen to have one. Just put parentheses around your fraction to protect it. And then when you're finished, you can hit that math magic button that gives you a fraction after you type in a decimal. Okay, another example. We want to find the sum of the following. I have a starting value of k. Notice I changed up these symbols. It doesn't matter what that letter is. It could be k. I've seen n. I've seen I. I've seen r. I've seen t. I've seen all kinds of things. This is just what you plug in to your formula. You can call it whatever you want. So I want to find the sum of the following. I'm going to start with the first term, and if you notice here, I'm going to infinity. That means I need to find an infinite sum. And if I look here, I have a geometric series because I have my first term, my ratio, and then I have an exponent. So my first term, if I want to know what that is, I have to figure out what happens when I plug a 1 in to get my first term. Well, I get 7 times 1 over 6 to the first, which is 7 1/6. But I never write it that way because it's not that useful in math. I need to write it as a fraction, improper fraction. All right, so that is my first term. That's a1, and my ratio is 1 over 6. So I can go back to the formula that we learned before and find the infinite sum. My ratio, if you'll remember, has to be less than 1. So if I plug in my first term, 43 over 6, divided by 1 minus 1/6, that's going to equal 43 over 6 divided by 5/6. And then I'm going to reciprocate that and multiply. And the 6's cancel out, and I'm left with 43 over 5. Not bad. All right, you guessed it, for you to try. Go ahead, pause the video, restart it when you're ready to check your answer. Okay, so I have another infinite sum. If I plug in a 1, I'm going to get my first term. 4 times negative 0.37 to the 1 minus 1. This is all going to equal 1. So my first term is equal to 4. And if you'll notice, my ratio is negative 0.37. And because my ratio is less than 1, I do have an infinite sum. It does converge, it doesn't diverge. So I'm going to use the formula for an infinite series. 1 minus negative 0.37 is going to give me 4 divided by 1.37. I have to add here because it's a double negative. And that's going to be somewhere around 2.92. All right, that's it. That's that simple. See you in class next time.